Okay, so people, here we go. Let's look at this step by step. This highest common factor type question, as I had spelled out, if you look at the base 2 to the power x plus 2 minus 2 to the power x plus 1 is equal to 128. So what you do notice is that for the bases, they are the same, but there's a minus sign. It's separating the terms, so we can't apply law number 1 of exponents. But in this case, because there's a minus sign that separates, we think of factorization. So it's 2 to the power x. The exponent's coefficient is the same. It's 1 here. It's also positive 1 here. So because the exponential coefficient for the variables is the same, that's why we understand that we'll be applying highest common factor. Okay, so what we do is we split 2 to the power x plus 2 to be 2 to the power x times 2 to the power 2, and we split the base 2 to the power x plus 1 to be 2 to the power x times 2 to the power 2 to the power 1, which is equal to 128. So after splitting the places, we take out the highest common factor. Usually it is the base with the variable exponent, so the base 2 with the variable exponent x, we'll take that out as our highest common factor, so that we are left inside the bracket with numerical exponents only. So 2 to the power 2 minus, on the left we are left with 2 to the power 2, on the other side of the minus sign we're left with 2 to the power 1. That's what's left behind. 2 to the power 1 is actually equal to 2. Whether we write that 1 on the top is of no significance. 2 to the power 2 minus 2, then we sort out the bracket, which is 2 to the power 2 minus 2, by simplifying that. So 2 to the power 2 is 4, 4 minus 2 is 2. Then after that, what do? We divide both sides by the isolated numerical value that is next to the base variable exponent. Okay, and we kind of treat this as a variable, all of it, and then this is the numerical coefficient. So whenever we have a variable and a numerical coefficient, we divide both sides by the numerical coefficient, as you can see here. That leaves us with 2 divided by 2, which is 1. We're left with 2 to the power x on the left. Then we do that same thing on the right hand side. 128 divided by 2 gives us 64. Then we apply 64 is equal to shift fact using our scientific calculator. If we don't know what the prime factorization of 64 is, we get 2 to the power 6. The bases are the same, and as per the rule that applies to exponential equations, when the bases are the same on either side of the equal sign, we drop the base and we equate the exponent. So the answer is x is equal to 6. That is the highest common factor type. If we go over to my other side, the trinomial K method type, we have 3 to the power x minus 3 to the power 2 minus x is equal to 8. For the same basis, base 3, the variable x, the exponent, has a coefficient of 1 here, but on the other side we have a coefficient of x which is negative 1. Okay, yeah, negative 1. So because one is positive for the variable and the other one is negative for the same coefficient 1 for the variable, then we know that that is the trinomial K method type. It's the same even if, like, let's say there was positive 2 here and there was negative 2x as your coefficient, then we would also apply that as being the trinomial K method type. Okay, yeah. So guys, as long as the coefficients for the highest common factor type, if it was 2x here and it was 2x, as long as they are the same, we know it's the highest common factor type. But the trinomial K method type, for the same base 3, for 2 different terms, we'd have a coefficient that's positive. So since it's 1 the coefficient, it's positive, and it's 1 the coefficient but it's negative, then we know it's the trinomial K method type. So what do? We split the bases as we have done here. 3 to the power 2 times 3 to the power negative x, which is equal to 8. We then rewrite 3 to the power negative x as the positive exponent. When we do that, we know that the base changes position, so it goes to the denominator, and its variable exponent changes from negative to positive. So we have 3 to the power 2, which was multiplied, but now it's divided by 3 to the power x, which is equal to 8. That's applying the negative exponent to 3 to the power negative x to become 3 to the power x in the denominator. Then 3 to the power x minus 9 over 3 to the power x is equal to 8. What we then do is we take the LCD. We know that the lowest common denominator here, the only denominator, is 3 to the power x. So we multiply each term by the LCD. Why do we do that? To get rid of the denominator. At this point, if we wanted to, we can let k be equal to 3 to the power x. That means everywhere where k is, 3 to the power x is, we substitute it with k. So here we substitute k minus 9 over k, which is equal to 8. Then we take that LCD, which is k, we multiply each term by that. So we have k times k, which is k squared. We multiply by k here, it gets rid of the k in the denominator. We multiply by k to 8, we get 8k. Transpose the 8k, we got k squared minus 8k minus 9, which is equal to 0. That's the standard form. We then factorize this, obviously. Since the sign for the constant term is negative, that means we're going to have different signs inside the bracket, but the highest factor of 9 will have a negative sign. And remember, these factors that we choose, when we multiply, we need to get negative 9. When we add, we need to get negative 8. So negative 9 and plus 1 qualify, as the product gives us negative 9. The addition of negative 9 plus 1 gives us negative 8. Then after that, what do? We use the zero factor law. So k is equal to 9, because 9 minus 9 gives us the 0. Or k is equal to negative 1, because negative 1 plus 1 gives us 0. What we then do is we substitute that k is equal to 9, the k is equal to negative 1. Back where we had set up letting k be equal to 3 to the power x. So that means 3 to the power x is equal to the k value is 9. We can then obviously use the shift fact. 9 is equal to shift fact, get 3 to the power 2. Bases are the same, we drop the base, we equate the exponents. 3 to the power x is equal to negative 1. Unfortunately, the bases have different sign values, so therefore we know that there's no value that we can substitute in the place of x as an exponent which could make this become negative. So we know that therefore the value of x does not exist, so therefore we say there's no answer, or there is no solution. Okay guys, I hope that helps resolve the battle between the highest common factor type and the trinomial k-method type. I hope you will be able to identify the two questions when you do see them in the exam paper. Thank you very much. I hope you have an amazing, stellar day. That's the game. Let us play.